Hey, hello everyone. Welcome to the video on simulation on ABC to dq0 transformation. In this ABC to dq transformation, we are going to convert the instantaneous ABC quantity at each bus into park transformation, that is dq0 transformation. So to simulate these systems, I am using this diagram, single line diagram, as a reference. So where two sources are connected to the transmission line, and there are three buses, and on each bus there is a load connected, which is a star connected load is given. So to simulate these systems, we need a three-phase source. So from the MATLAB, I have copied this three-phase source. How to get? Double click on the screen, type three-phase source. Okay, type the three-phase source. So once you type this three-phase source, the three-phase source will appear here. So likewise, I need two sources. So the first source and second source. It is connected by the transmission line. I need two transmission lines, so I will place two transmission line one after another, and I will before joining I need to connect the bus in between. And at each bus, how we want measurement bus. Many times this is confusion in the mind that how to create the bus. Now to connect this transmission line, we need a bus 1 here, bus 2 here, and bus 3 here. So how to connect this bus 1, bus 2, bus 3? Let's see. First we have to rotate this block. So click on the block and place the control rotate. So control R. So control R will rotate that image. But if you see here, in this ABC is appeared here, and here it is a CBA appeared. So how, but we want it as a ABC phase. So how to change that? Let's see. You click on right click, then click on the format, then in the format you go in the flip block, and I want left to right change. Okay, format, flip block, left to right change. Sorry. Okay, and then if you see the rotation, so it will get ABC phase. Okay, again rotate it, you will get ABC. Now you can connect this, but before connection of this we need bus in between. So how to create the bus? So we have a three-phase VI measurement block. Three-phase VI measurement block can be itself convert into the bus. So how to convert this into the bus? Let's see. Double click on this block. Okay, three-phase VI measurement. Here I want to measure the phase to phase voltage. Okay, I want to measure the phase to phase voltage. I will give the nomenclature to this as I am creating for bus 1. So I will give this name as a VABC B1. I want to measure the current also. I will use as a label again, current measure, and I will give the name as IABC underscore B1. Apply. Okay, so you can see here now that measurement are absent here. So VABC and IABC, it is having only input and output ports. Right click it, go to the format. Okay, in this go to the format, then change the background color to black. Okay, and reduce this. Okay, and I will give this name, change this name here as a bus 1. Okay, so likewise I have created the one bus which I want to place over here. So okay, so as I created this bus 1, similar bus I will copy here. So one bus more is copied over here, and third bus is copied over here. So bus 1, bus 2, and bus 3, you can see. Now I will connect this. Click on the first source block, press the control button and click on bus 1 block. It automatically get connected. This is also get connected. This is also get connected. Control, then next block, control, then next block, control, then next block. Now we have to give the all parameters value here. So how to give these parameter values? So let's check. This is a three-phase VI source. In this three-phase VI source, it is given as 500 kV and short circuit MVA is 3000 and X by R ratio is 8. So double click to this block. Okay, so then you change this configuration as, so here I am creating this voltage as a YG. Then phase to phase voltage I need a 500 kV, so 500 e raised to 3. Frequency I'm getting 50 hertz. Here I want to specify the parameters on short circuit level, so I will click on the short circuit level, keep it at internal and short circuit level. What is the short circuit power is to be set? It is 3000 MVA, that is 3000 e raised to 6, and voltage is 500 e raised to 3, and x by r ratio I am changing it to 8. Okay, so 8 or 7, let me check, it is 8. Okay, so x by r ratio is 8. Apply. Okay, this first block is set. Now second source I will set. Second source is also yg. Voltage is 500 e raised to 3. Frequency is 50 hertz. Then short circuit level for this, again it is based on the 2500 MVA, 2500 MVA e raised to 6, sorry. Then it is 500 kV, that is 500 e raised to 3, and short circuit ratio, the x by r ratio is 7. Apply. Okay, so I have set this both parameter on both sources. Now let's change the transmission line parameter. What are the transmission line parameters are given in this year? So transmission line is 3 phase, line length is 300 kilometer. Okay, R1, R0, these values we need to be fed. So frequency is a 50 hertz. So we need to give the values of R1 and R0 per kilometer. So R1 value is 0.01755, and second one is 0.2758. Inductance value is given in this block. So what is the value of the inductance? 0.8737, 0.8737 millihenry, so that it is e raised to minus 3 per kilometer. And the L1 value, L0 value is 2.22 millihenry, 2.22 e raised to minus 3. Similarly, we will specify the capacitance. Capacitance value is 13.33 nanofarad per kilometer, and C1 value is, C0 value is 8.297, 8.297 e raised to minus 9, that is nano farad per kilometer. So these parameters are applied. Okay, so as I said, the parameters for the transmission line 1, transmission line 2 is similar. So I am just right click and dragging it, and I will place this line over here. Now it is also connected in the system. So likewise we have uh, completed our power circuit. So let's check the performance of a power circuit. Still we have to connect the loads in this system, how to connect these loads, and let's check. So for connection of load we need RLC load. So take this RLC load. Okay, so if we look to the first RLC load, it is a 100 megawatt, 500 kV, and Y connected. So double click on that, it is a Y connected with ground. Phase to phase voltage is 500 e raised to 3. Frequency is 50 hertz. I'm setting only for active power with 100 megawatt, so 100 e raised to 6. Reactive power I'm keeping 0. Apply. Okay, so the load is only resistive. So I will connect this load to the respective bus. Okay, so I can connect this load to the respective bus, bus 1, bus 2, and bus 3. Okay, further you can if you want, you can reduce that size to adjust. Okay, so I need such 3 loads. So first second load I will take here. In a second load there is only one change, that is load is of 2 megawatt. So let's check, load is of 2 megawatt. So I have connected these 3 loads in this system. Okay, if it is not connecting, just move the diagram. I want to move this. Okay, so connect this. Then I need to connect the third load at the third source. So connecting the third load at the third source. So this load is second number load is of 2 megawatt. So it is 2 e raised to minus 2 e raised to 6, and third load is of 300 megawatt. So this load is 300 megawatt. I am changing. Okay, so let us connect to the respective phase. Okay, now I want to observe the waveform, so let's save the model. So I have saved this model. Now I want to observe the waveform at each bus. What is the voltage and current at each bus? To simulate this system, we need the power GUI block. So right click and mention it is a power GUI. Click on power GUI. So it will give you the power GUI block. I will place this power GUI block over here. Okay, power graphical user interface. Then later on, as I want measurement, so I will reduce this diagram further. So right click and give the name from. Okay, so if you look to the bus voltage of this bus, it is VB1 IABC1. Here again I have to change this as VABC2 IABC2. Okay, here I can change VABC3 IABC3. Okay, so for I will observe only the voltages of bus 1. So here I am giving the same name VABC underscore B1. Okay, if I press the updated tag, okay, it is not updating because names is not matching. So see what is the name given over here. Underscore b1, so same name should be appear here. So VABC underscore b1, this is my tag, update tags. So it will update the tags. The another way to do this, okay, another way to do this same, I'm copying here. I want IABC, just click here on the name. Sorry, just click here on the name. It will give the list, whatever the taggings are there. So I need IABC B1. Okay, and I need to observe these values on the scope. So I will press the button of scope is taken over here. Double click to this scope, it will open its menu. Okay, the scope is appeared over here. Now I will click to this setting, configure parameters. So I want two input ports, and layout is in a column format. Apply. Okay. Okay, now you close this. Connect the first measurement block here, connect the second measurement block here. Double click on the first line and give the name VABC of bus B1, which is given in terms of kilovolt. Here IABC B1, which is in terms of ampere. Sorry, this is not in kilovolt, this is also in volt. Okay, so these names will be appear in your graph. If you select over here, uh, okay, if you okay place, then whenever we run this, it will, you are able to see that names on. Okay, sorry, come to the display. Okay, okay, so let's now run this model. So I will set this simulation time to 0.1 second. Okay, simulation time to the 0.1 second. On the bottom side, come to the solver setting. Okay, in the solver setting, what we have to do, we have to change the solver setting. Let's change the solver setting. Variable step. Here you choose the 23T mod steep trapezoidal solver. This is the best work. This solver will work based on the power system block set. Then click the OK. Okay, so now here ODE 23T is appear. Now run this model. It is compiling. First time it took the time to simulate. Okay, now it's initializing and it's running. Okay, so total simulation is completed. Now let's observe the scope. So you can observe into this scope the voltages and currents. So VABC B1 and IABC B1, these voltages and current are observed over here. So likewise you can see the graph of bus 2, bus 3, bus 2 and bus 3 by changing this name, or you can create a separate block for that. Hope you understand this, how to simulate the power circuit. In the next video, I will tell you how to convert this ABC quantity into dq0 quantity. If you want to copy this simulation graph, just click on right click, style. Okay, you go into the style. Then you can change this figure color to white, axis color to white. Okay, if you want this with the bigger size, you can give for line 1 apply. Okay, so yellow is in bigger size. Then for line 2 also I can give apply. Okay, for line 3 again I am changing this font, because line width is B. So see, but for first is R actually phase. So if you want to change the color also, you can change the color. The first is the red one, second one is the blue, and second one is the yellow, and the last one is the blue. Then you can press the apply. So RYB. Similarly on bottom axis also you can change the style. The first is 2 R color, then second width is 2, then Y color, then for a third width is 3, and then blue color, sorry, width is 2, apply. Okay, so you can observe the voltages and current. If you want to change the axis properties also, that also you can change, or you can export this graph. uh, you can preserve this color to copy to the next block. So you can change this axis name whatever you want. You can save into the fig file, export as a fig file from here, export print to the figure file, and then figure file you can do whatever you want to do with this figure. Okay, so if you want to change the font, change anything. So I have clicked this print to the figure. Now see, it is a print to the figure. It is different window is appeared here. Now here I can change. This is a figure window. Now here I can change with the help of property editor block. Okay, opening the property editor block. Just a minute, it is appearing. Okay, using this property editor block, if I want to change this axis name over here, then I can change this font size as a 14, any font if you want. Then color of this I want black color, black. Okay, then I want to change this. See, it is changing. Similarly, I want to change the current of I want to change the size of this. I want the size this 14, and color is black, so it is changing. I can change this font, I can change this font, whatever you want you can do, and just you can close this, and you can save the waveform for further references. Okay, so hope you understand this video. Thank you.